Okay, good morning, everyone. In today's lecture, we'll start with the theorem, Dirichlets theorem. As I said, this theorem actually reduces your calculations under certain conditions. Uh, the triple integral, four integrals, or five integrals, two integrals, whatever the number of integrals you have in terms of different variables. In 2 to 3 steps, we can actually give the answer, but provided those things are under certain condition. And the theorem states that, I will just write down the general theorem first of all. The theorem states that dot dot dot. We have x1 raised to L1 minus 1, x2 raised to L2 minus 1, dot dot till xn raised to Ln minus 1 dx1 dx2, actually dxn n minus 1 up to dx1. The value of this integral is equal to gamma of L1, gamma of L2, gamma of Ln upon gamma of 1 plus L1 plus L2 dot 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 till Ln. So there is a condition on this. So what do we see here? This is integration with respect to n distinct variables. And what are the variables here? X1, x2 up to xn. What is the integrand? Again, integrand is to be understood properly. It is the product of all the variables, whatever number of variables you have, x1, x2 up to xn, and they have certain power. So in that case, the value of the integral is this, gamma of each and every term upon 1 plus addition of all the powers. Where we will have this value, where the integral, the integral is extended to all positive values of the variable subjected to the condition x1 plus x2 plus dot dot till xn is less than or equal to 1. So what do we understand? Uh, if your integrand is just the product of all the variables, and whatever volume over which you are integrating, say if this integration is over V, then in this V, all the variables are positive. You can see here, where the integral is extended to all the positive values of the variable. Okay, and in this V, the addition of all the terms x1, x2 up to xn, this has to be less than or equal to 1. So, in which examples you can use the Dirichlets theorem? The first one, where integrand is the product of the variables and you have some power. Second thing, the volume over which you are integrating, in that volume, all the variables are positive, and if you add the components at any point, then that summation is less than or equal to 1. So to understand this better, I will write two cases which we will of course need in further examples. The first one is for two variables. For two variables. So if you have integration over the region R, x raised to m minus 1, y raised to n minus 1, dx dy. Then this will be equal to, yes, anyone? Khushi Sahu, Rohit Raj,
Yes, sir.
yes, what will be the integration here? That is Sumedh.
Sir, gamma of n into gamma of m
Huh,
upon 1 plus into upon gamma of 1 plus m plus n.
exactly. Just tell me, Sumedh, what do you have in the first lecture today? I mean, on Thursday, what do you have before mathematics lecture?
Before mathematics, it is BC, civil
BC,
engineering.
it is theory lecture or it is practical or something?
No, it is theory.
Theory. Okay. So you do the tutorials or physics. Why is it so that on Thursday everyone is a lot inactive? Anyways,
I don't know, sir.
anyway,
Sir,
so
continuous 3 days, sir. ICs and engineering graphics exhausted our mind.
okay, gamma of m, gamma of n upon 1 plus m plus n. But this will be possible only if in R two conditions hold, x comma y, both of them are greater than or equal to 0. So x and y should not be less than 0, and x plus y has to be less than or equal to 1. So if these conditions are satisfied in R, then this integration will be this. And for three variables, a triple integral over the volume V, x raised to L minus 1, y raised to m minus 1, z raised to n minus 1, dx, dy, dz. This is equal to gamma of L, gamma of m, gamma of n upon gamma of 1 plus L plus m plus n. So you can see that this is a very strong theorem. And again, the condition in V, x, y, z, all of them are greater than or equal to 0, and x plus y plus z is less than or equal to 1. If these conditions are satisfied, then and then only we can use the Dirichlets theorem. We'll solve just two examples, not many in this case, as it is very easy.
Excuse me, sir.
Yes,
Sir,
Sir, can
can
you show
you,
the earlier page, please?
sir, first slide, sir.
this is the previous one.
After, before this, sir, I have to take a
No,
screen. Yes.
Fine.
Done, sir.
Fine. So example, evaluate triple integral x square y z dx dy dz throughout volume bounded by the planes x equal to 0, y is equal to 0, z equal to 0, x by a plus y by b plus z by c equal to 1. I'll draw the diagram first of all. Look, A, B, C, what do they represent is the x-intercept, y-intercept, and z-intercept. I mean, if you put here, say A is y and z as 0, so what you are going to get x equal to A. So the x-intercept will be A 0 0, y-intercept will be 0 B 0, and z-intercept is going to be 0 0 C. So this is just the tetrahedron that we saw in the first lecture while we were solving triple integral. And this is the volume over which we have to evaluate. So can someone tell me now? What will be the integration? You can at least try. You may be wrong, but think over it. What will be the integration here? Okay, are the conditions for Dirichlets theorem satisfied?
Yes.
So then what is the answer if conditions are satisfied? Hey, Yashraj,
For all the variables are greater than 0, matlab positive.
yes. What is the other condition? Sahil,
Yes, sir.
yes. Tell me, what is the integration here?
Sir, no idea, sir. I'm trying, sir.
So here we
Very
have
good.
to state that ABC would need to be less than 1, no?
Sir,
Yes.
gamma 3, gamma 2, and gamma into gamma 2
Okay.
upon.
And that others, you are on right track. Speak up.
So we have to say that ABC should be less than 1 for the condition to satisfy.
Yes. But is it given that ABC are less than 1?
No, sir.
No. Exactly. So what can we do? So we know that in Dirichlets theorem, if I take any point in this volume, then if I add the coordinates, that has to be less than 1. So x plus y plus z in this case will not be less than 1. Okay, so I will have to make some changes in such a manner that the new variables will have addition less than 1. and all of them will be 0. So what can I do? Put no one. What can we substitute so that the new variables will have addition less than 1? Very easy. I don't think it is that difficult. Chirag Agarwal. Pratham Adhikari. Harshal Chauhan. Mrunal Dande. Rachna. No one.
Sir, can we put y and z is equals to 0?
वेरी गुड. ये तो फिर हर इंटीग्रेशन ऐसे 0 हो जाएगा फिर अगर सब सब्स्टिट्यूट 0 कर देते हैं तो. राशि जैन. यश निकुंभ. Can't even identify substitution. Diksha.
Can we put -1?
What -1?
Sir, z and y as -1. So the value of addition will
Why?
come less than 1.
No. Sonal Singh. Yash. Any one of both of you. Vatarkar or Vatekar. Yes, tell me.
So thinking.
Thinking. Sumedh.
Sir, we can convert it into polar coordinates by putting
Why polar? बाबा. Circle है नहीं है तो polar जाना ही.
sir, elliptical.
And
elliptical
anyway
I
in
mean.
3 dimension we don't have polar coordinates.
Sir, elliptical coordinates.
No. So the proper
Conjugated-
substitution is
It's
I'll put x by a equal to u, y by b is equal to v, and z by c is equal to w. Now we can see that in this case u plus v plus w, this becomes less than or equal to 1 in the volume V, as well as all of them are greater than 0. So if we make this substitution, dx will be replaced by a times du, dy will be replaced by b times dv, dz is replaced by c times dw. Let's substitute all these values. So what we get is triple integral a into u whole square, b into v, c into w. Dx is a du, b dv, and c times dw. So as we can see now, u, v, w, all of them are greater than 0, and their summation of all the variables is less than or equal to 1. So we'll have a square, a cube actually. So if we collect all the ABC are constants. So constant can always be taken outside the integration. So a cube b square c square. We'll have triple integral u square vw du dv dw. Now on this part, I can use by Dirichlets theorem. What I will get is e cube b square c square by Dirichlets theorem, gamma of 3, gamma of 2, gamma of 2 upon gamma of 1 plus 3 plus 2 plus 2. So gamma of 2 is 1, gamma of 2 is 1, gamma of 3 is 2. And in the denominator, we will have 5 and 2, 7 and 1, 8. 8 is nothing but 7 factorial. So if we do all the simplification, what we get is e cube b square c square upon 2520. So this is how we use the Dirichlets theorem. So if it is a MCQ 1 mark question, so maybe that the region itself is satisfying the Dirichlets theorem. But there is another way that if your region is not satisfying the Dirichlets theorem, what we can do is we can make a proper substitution in such a manner that all the conditions for Dirichlets theorem hold, and we will be able to find the full integral. Next example. Evaluate triple integral x, y, z, dx, dy, dz taken throughout the ellipsoid. Upon c square less than or equal to 1 in first octet. What will be the substitution now? Substitution is, yes, be quick. Now we have solved one example, you have the idea. X square upon a square equal to u, y square upon b square equal to v, z square upon c square equal to w. X is equal to a root u, y is equal to b root v, z is equal to c root w. So dx is equal to derivative of root x is equal to 1 upon 2 root x. So that will be a into u raised to minus 1 by 2 du. dy is equal to b into v raised to minus 1 by 2 dv. And tz is equal to c into w raised to minus 1 by 2 dw, and divided by 2 for each and every one. A by 2, b by 2, c by 2. So if we substitute these values, I'll get triple integral x is equal to a root u, b root v, c root w, dx dy dz will be ABC divided by 8 to u raised to minus 1 by 2, v raised to minus 1 by 2, w raised to minus 1 by 2, du, dv, dw. So plus 1 by 2 minus 1 by 2 will get cancelled out, or it will turn out to be 0 in all the three cases for u, v and w. We will have a square, b square, c square divided by 8. Triple integral du, dv, dw. So on this case, I can apply the Dirichlets theorem, and what do we have? A square, b square, c square divided by 8 into gamma of 1, gamma of 1, gamma of 1. All of them will be 1 upon gamma of 4, which is 3 factorial. Just like this is the final answer.
Sir, once you can show previous example. Okay, sir.
So the next thing we need
Sir,
to
can
see.
you go back to the slides, sir? I want to take a screenshot, sir. Sir, okay, done.
So the next thing we need to see is the applications of this multiple integrals. Application of multiple integrals. The first thing that we will see is the area. The first application is area. We can find area of the different regions using the double integral. And so area of a region R on a plane in Cartesian form. In Cartesian form is given by double integral over R 1 dx dy. So what does the statement say? You have a region which is given in Cartesian form, and I want to find the area. So if I want to find the area of a region, what we do is we simply take the double integration over that region with integrand as 1. In that case, the answer whichever I will get, it is the area. Note that this is in Cartesian form. Cartesian form mein integrand is 1. So area of a region R on a plane in polar form, polar coordinates, polar coordinate system is given by. Yes, can someone identify? You need to double integrate over R. As we said, integrand is 1, but dx dy, when you convert it to polar form, what we have is R dr d theta. So if you are working with polar coordinate system and you need to find the area, so integrand becomes R So this is nothing but area. This is in polar form. Whereas if you are in Cartesian form, the integrand becomes 1. One small remark that, say for an example, I want to find area of a circle. Okay, and this much area, this is A1. Then the total area of the circle is 4 times A1, right? So the point I want to make is, while you are finding out the area of a certain region, we can always use the symmetry. Look, when you are solving an integration over a circle, if you are finding out the integration, in that case, you cannot use the symmetry. Okay, remember that. Until and unless your integrand is 1, integrand is not 1, you cannot actually use the symmetry. Fine, we'll make the remark and immediately solve the example. Remark. While finding area of a region R, symmetry of region, the region can be used. Example, find the area bounded by y square is equal to x and x square is equal to minus 8y. So y square is equal to x is a parabola which is opening towards positive x-axis. What about the second one? X square is equal to minus 8y. It is a parabola opening towards negative y-axis, so they will have some intersection. So this is the area which we actually need to find. Let's find out the points of intersection. One is of course 0, 0, and this point is going to be, so have to substitute one in the other. So x is equal to y square. So we'll have y raised to 4 is equal to minus 8y. So y raised to 4 plus 8y is equal to 0. So y common, y cube plus 2 cube equal to 0. So in that case, y is equal to 0 or y equal to minus 2. So if the value of y is minus 2, the value of x will become 4. You can see that the condition is satisfied and the 2 points we have got. Now we need to take the step either vertical or horizontal, whichever we like. I'll take the vertical step like this. So area is given by double integral over r dx dy. Now the value, I should give the limits. The vertical step will start moving from 0. Oh, I've done something wrong there. The point has to be 4 comma minus. Four comma minus 2. X is running from 0 to 4. Y is running from this parabola, which is minus root x, to the upper parabola. The value of y is x square divided by minus 8 dy dx. So this is 0 to 4 x square by minus 8 minus of minus plus root x dx. This can further be integrated. So that will become x cube divided by minus 24 plus x raised to t by 2 divided by t by 2. Values from 0 to 4. At 0,
Can
both
you
the values
explain
are
once again how did you get the limits of y?
It's simple to double integral, na? Lower limit to upper limit, which is this is the lower limit, this parabola, this one. What is the equation of this parabola? Y square equal to x. The value of y is going to be the root x, negative root x, because in the lower quadrant the value of y is negative. To the upper limit of the strip is this parabola. On this parabola, equation is x square equal to minus 8y. So y will be x square by minus 8.
Okay.
This is done in the previous lectures. So 4 cube divided by minus 24 plus 8 divided by 3 by 2. This can be solved and the final answer is 8 by 3. Check the calculation.
Sir, please show the applications slide once. Done, sir.
Next example. Find the total area of r is equal to a 1 minus cos theta. We know the equation. This is an equation of cardioid, and the cardioid looks like this. Okay, things are better when we are dealing with cardioid in polar form. In polar form, the area is given by double integral over r into dr dt. Now in this, the curve is symmetric about x-axis. Curve is symmetric about x-axis. So area of the lower part and the upper part are going to be the same. So For that purpose, what I will do is I'll just take the upper part and multiply it by 2. So this is my R. So area is equal to 2 times integral over R dr d theta. Now, as we are working in polar, take the strip starting from the origin and to the curve. We can see that the strip theta is going to be running from 0 to pi. R is running from 0 to the curve. The equation of curve is A
1 minus
1
cos theta.
minus cos theta R dr d theta. This can be solved now. 2 theta is running from 0 to pi. A 1 minus cos theta d theta. So I'll have 2a outside. The integration will be theta minus sine theta 0 to pi. So at 0 as well as pi, sine theta will become 0. Just have we will have to 2a pi is the 2a pi. Am I right?
Sir, it should be r square by 2. No?
Yes, sir. It should be r square by 2.
Just a minute. Yes, sorry. This integration, this step is become from this. So this is 2 times 0 to pi r square by 2 limits from 0 to a 1 minus cos theta d theta. So in this case, 2 will get cancelled out. And when we put the upper limit, we'll have a square 1 minus cos theta square d theta. So in this case, a square being constant will come outside. What I can do is I can either expand it, or what I can do is 1 minus cos theta is equal to 2 cos square theta by 2. So 2 cos square theta by 2 will become 4 cos raised to 4 theta by 2 d theta. Please check the calculations. The a square outside. So this is 4a square. And if we put theta by 2 is equal to t, so we'll have cos t d theta is equal to 2 times dt. So that will become 8 dt. Please check the calculations. Theta by 2 is equal to t. D theta is equal to 2 times dt. Moreover, when theta is equal to 0, t will become 0. When theta is equal to pi, t will become pi by 2. So cos raised to 4. Now cos raised to 4, I can use the reduction formula there. So we have 8 a square by reduction formula. We'll have 4, 3, 2, 1, pi by 2. This 4 into 2 into 2. Oh, sorry. Only 1, 2 will get cancelled. So the final answer is 3 a square pi by 2.
Sir, how 2 theta is there, sir?
How?
No, sir, sorry.
one.
Sir, 1 minus cos theta is sin theta.
Are you sure?
1 minus, right?
1 minus cos square is sin square.
No, 1 minus cos theta, I'm saying.
1
Is
minus
equals
cos
to
2
1
cos 2
minus cos
sin
theta
square.
is equal to 2 sin square theta by 2. 1 minus cos theta is equal to 2 sin square theta by 2. 1 plus cos theta is equal to 2 cos square theta by 2.
Sir, can you shift to the previous slide? Sir, it is minus, right?
So this will be sin. Yes, thank you.
That's what I was saying.
But cos or sin, the final answer got correct because this formula is reduction formula is same for power of sin and cos. Okay, anyway, thank you. Fine. Find the area of the region included between two cardioids. R is equal to A1 plus cos theta and R is equal to A1 minus cos theta. So we know that one opens towards positive x-axis and the other opens towards negative x-axis. Yes, which is the symmetry here. Your region is going to be symmetric about both x as well as
X and
y.
Y.
So if I just find out this area, that would be fine for me. And I'll multiply it by 4.
4 is from 0 to pi. 0 to pi by 2.
Area is equal to 4 times integral over r. Integrand is r dr d theta. So that will be 4 times integration. Theta is running from 0 to pi by 2. R is running from, the strip will start from origin and go to this curve. This curve is the parabola, cardioid opening towards negative. Negative वाला कौन सा है? 1 minus cos theta. Are you sure? Yes. So R is running from 0 to A 1 minus cos theta. R dr d theta. This can be integrated. Theta is running from 0 to pi by 2. Integration is r square by 2. 0 to A 1 minus cos theta d theta. So this is 2 times 0 to pi by 2. So it's A square 1 minus cos theta whole square d theta. So this is 2A square Again, this I will solve by some other method. Say I will square it 1 minus 2 cos theta plus cos square theta d theta. That is one way of solving it. You will have to solve it separate for each and every one of them. The other way is you use your reduction formula here and tell me the answer. We'll go ahead. Again, you will have to do the substitution if you use 1 minus cos theta formula. So the answer to this is 2a square 3 pi by 4 minus 2. Fine, so that's all for area. In the Monday's lecture, we'll complete the volume. This is the application of triple integration. It is just the same like we have done the area over here.
Sir, you haven't uploaded the double integral video, sir, in the YouTube channel.